ObaSan, good morning to you in New York, and it's 10 p.m. in Mumbai, India, and thank you very much for being there for me and taking up one of my queries, which I was quite curious about because I don't see TPM occurring anywhere. I didn't see TQM. I was only saying TPS, etc. Then I said, let me dig out and find out the most authentic source that I have is in Haidobe. So I requested Haidobe-san to tell us where does all these things of TPS, TPM fit into TPS, TPM, and TQM fit into the TPS journey as we know it. So that's going to be that's what I requested, and thank you very much for doing a lot of research on that. And so this is a research document. Let me do my standard work because all of you have drilled into me, including my sensei Master Kimai, that start with standard work. So let me do my standard work of introducing you to you.
Mhm.
Hey, here we go.
Oh,
Right, here we go. Well, ObaSan, you're welcome to Dr. M's VODCAST. You're on the 55th episode. And by now you have been on 6 of my episode. And thank you very much for adding to my digital library. And you know that I share all my videos across and I got no copyrights, etc. So here we go. You're on the 55th episode, and that's why I put the curtains on. And welcome then. Hi, Dobe. You're going to talk about KANRI, lost in translation. And I won't know much about it, but I'm leaving you to tell us where did we lose in translation. So, Obe-san, born in Nagoya, everybody knows two things. Everybody knows Nagoya, and by now everybody knows you very well in not only in LinkedIn, globally too. Well, you lived in Japan and your father was here, which I'm sure you will talk about Hijame Obe-san, whom we have a great respect for in Kentucky. And you started working, makes it 24 years in TPS. Well, this part of it, all of us knows, but standard work, I need to. You all told me the standard work has to be documented, so I'm documenting it. Am I correct? So I'm documenting.
yes.
Implementing TPS system philosophy to drive change in organized to accomplish business results for 24 years now. You have worked in many kinds of industries, various operations, uh, industries like automobiles, energy, food, etc. And in various countries too, with different cultural backgrounds. And you worked with cross-functional teams and developed and implemented, executed corporate-wide training, which balances both on-the-job training and off-the-job training. And that's what gets us growing. And thank you very much for all your contribution to us, continuous improvement professionals across the globe. So, Obe-san, here we dart across to you. Over to
Mhm.
you and take it to Obe-san and talk to us, KANRI lost in translation. I do
Yes.
not know what KANRI means. So I'm going to stop sharing and handing over the
Hold on.
presentation to you.
Yes,
Oh,
I'm trying. There.
great.
Sorry. Hold on. I'm trying to go back. Okay. Sorry. Ah,
That's great.
right. So, Dr. M, thank you very much for this opportunity. I'm quite surprised that I've been here 6 times, but I always enjoy being on your show. And it's also a good opportunity for me to summarize a lot of topics that, I wanted to summarize beforehand. And yes, we started discussion about what's the relationship between TPS, TQM, TPM, these Japanese activities that was born around the same time. and it seemed to be taught in a separate way. But from my point of view, I was trained to integrate. So let me go to those stories. Just to explain, I'm not gonna go over about my background, but I was coached by my father, Hajime Oba, who was a Toyota employee since 70s. And yeah, and he was working for the Toyota group, the TPS group, sorry, from the 86. And 1992, he started the Toyota Supplier Support Center, which implementing TPS to all kind of industries. And I joined his team in 2002. And I've been coached by him on the shop floor, but also at the same time, I was always challenged by him is, go back to the original book, original document to understand what's being said and be careful with translations. So, I read the English original books and I read the Japanese original books to compare, understand deeper. And the one of the things that I learned from my father, I always talk about this with Dr. M, is the structure, right? Behind every word he uses, there's a structure on the gemba of what that means. I need to understand what specific points he's talking about, line, area, and body, which also typically consists of mechanism and system that he is talking about. He he was very specific. He didn't like vague. He might be using a vague word, but he means something specific on the show floor, and I need to understand. So let me try to go through this version of my understanding of TPS, TQM, and TPM. What is the relation between these philosophies? Because I think most of what people will learn this separately, and that's simply because it's originally from a different organization in Japan. TQM is heavily sponsored by JUSE, the Scientific Association of Japan, and TPM is often sponsored by the JIPM, Japan Plant Maintenance Association, and TPS is from Toyota. And because of these different entities, they try to teach things separately, but I was taught to integrate them. And that comes from the Ono's quote, which he mentioned at the early stage that, the zero defect mentality is exactly same as TPS. It's one heart, one same body. And we don't want to treat them as a different system. So the important question for me was, what is that one heart, one soul that they're trying to accomplish? And then I move on to the next gentleman is Mr. Toyota. Why Toyota is important to understand the relation between the three is because he sponsored Ono to implement TPS. We all know this. But he is also the guy that implemented TQM at Toyota. So he heard about the work of TQM and he introduced to his bosses that TQM is necessary to be successful. And that's the reason why Toyota started implementing these things. And when I researched some of his quote, he has so many wise quote. One of the interesting quote he mentioned is that TPS is the technique or skill and law of KANRI. So he's starting to say that TPS is related to more about KANRI. It's not just the production engineering aspect. It's more about the KANRI. And that's the key word that I would like to focus this presentation about. There's another reason why I focus a lot on KANRI. And this is coming from the quote of Mr. Kusunoki, who is the second head of TPS group. So he succeeded the TPS group from Taiichi Ono, and he is the guy that sort of theorized TPS. And he's been obviously being successful about it. He was a student of Ono, but he wasn't like always obedient in some ways. One of the things he was frustrated about TPS was that there was no sort of like summarized book about it. So he formed a secret team against Ono that summarized TPS. And he allowed people to use his room, not the Obeya, but the small room that he had, and secretly summarize TPS. And that became the first textbook of TPS in 1973. And the TPS book that we read today, the Taichi Ono's Toyota Production System, this book was published based on that textbook. And he also wrote a book in the 80s. And inside this book, he's talking about 5 important things about Toyota's monozukuri, which means the manufacturing philosophies that he has, he think is important. I'm not going to talk too much detail about the 5 points, which each one of them is extremely important. But the part that is relevant to this discussion is the 4th point, where he is saying TQ and TPM, right? We need to unify these KANRI method. So from his point of view, and he is also a student of Toyota, AG Toyota, so his responsibility was to integrate these 3 systems, and to integrate his focus, and Toyota's focus is on this word KANRI. When you focus on this KANRI, we can integrate these 3 in a very good way. Now I start researching about KANRI, this word. And when I start reading a Japanese article, you will see, like, I don't know how many different KANRI exist in this area alone. These are some of the words that I found inside these TPS books. And I think there's more, and I can't keep up with it. And when I try to translate each one of them, we have so much flexibility in translating the word KANRI. For example, Hoshin KANRI, I'm quite sure a lot of people have heard this word, and a lot of people, including myself, have translated this as policy deployment. Does KANRI means deployment? Yes, no, maybe, I don't know if this is a good word. Another example that I really hate is the production analysis board, which is like also called like hour by hour board. And this comes from the word Seisan Kanri board in Japan. And somehow we translated Kanri as analysis. Is this a good translation? I had a many argument with my father that this is not a good translation, but we still use this word as a translation. And it just confuses a lot. So now let me try to go a little bit more to the original meaning of KANRI. KANRI is not a Japanese original word. It came from China. China developed this word. It originated around 17th century. So about 400 years ago, they developed this word, which meant to talk about the bureaucrats, and the administration is probably the best translation of how they use the word. The first part, kan, means it's bamboo. Bamboo, how can I say bamboo? Not a paper, but it's a bamboo stick that people used to write things on. And that was the official record of the government. And you sort those bamboos. The second word means science and logic. So how do we organize things in a logical way is the beginning of this word administration. And that was the original meaning of KANRI. When the Japanese people started to face the Western world, and eventually they were introduced to Mr. Taylor and his work on scientific management, we chose the word KANRI to translate management. We did not have any word that means management, surprisingly. And the best that we can think about what would be appropriate word was KANRI. And so there's a strong connection with this word KANRI and Taylor's work. For example, industrial engineering is from Taylor too. And some group of people in Japan translate industrial engineering as KANRI engineering. Engineering that provides some kind of KANRI activity to this production. we didn't directly translate industrial. In this particular case, somehow industrial became kanri. But because we use this word management and it's come from Taylor, I can see one important trend in Japan is that there's a strong association of management and standard. We believe the standard work came from Taylor, some of his followers developed the standard work. And therefore, when we talk about Kanri, it has a strong connection with standards. And I will come back and again on this topic because this is probably an important part that I need to talk about the similarity and the difference in Japan. Then came Dr. Deming. After the war, the Japanese people was introduced to quality control. And when we were introduced to this concept of statistic process quality control, we translated control as kanri. And that is because this translation was intentionally made by the Japanese people because during the war, the Japanese economy was controlled by the government. So we had a very strong negative bias towards the word control. So when the people who were introduced to Deming's thought that we cannot directly use the word control, we need to find a similar word that might mean similar, that could provide useful and acceptable to the Japanese public. And that's the reason why we use the word kanri here. And the other aspect of Dr. Deming's work that is important is the PDCA cycle, plan, do, check, action. And I know a lot of people talking about, no, it's not check, it's study or something detail inside this PDCA, but whatever that cycle is, we also call this cycle the kanri cycle. So making sure that we do PDCA means kanri to us. So there's a lot of different ways to think about management, but wherever there's a management, we think of Deming and having this PDCA cycle is critically important. Deming also introduced us to, statistic control is not just about inspection, but also designing and controlling the production processes better. And that way we can accomplish the thought. And this thinking start to proliferate and more bigger under different leaderships. And that leads to TQM. But there's another important gentleman. Before I talk about the Japanese TQM that I need to introduce is Dr. Juran. Some of the Japanese academics will say that they had bigger influence on quality control from Juran than Deming, depending on who you talk to. But a lot of the Japanese respect Juran as equal as Deming. And part of the thought is he was probably more practical than Deming. Deming was more of sort of a theorist. And because Dr. Duran used to work as an inspector in some factories, he provided practical advices to the Japanese. And here, when we talk about kanri, Dr. Duran probably used the word control means to prevent. I think that's the word that he used. Control means to prevent. But when we translated, this translation for Japanese became management means to prevent. So when I talk with people like my father, and they will say, like, why is this area not under kanri? What that means is why the management haven't prevented the problems from happening. So they might use the word like kanri condition. Is this condition really under kanri? Which means that all the problems should have prevented, and that means under control. And that's the part of the nuances, a slight difference in nuances, because a lot of places where I go to is this condition under management? And they will say, yes, because I have a manager. But that from their definition, it's not having a manager means under control. It means that there's some kind of preventive measures has been taken to prevent the problems from happening. Dr. Drang also left this interesting steps of TQM. Basically, he pointed out this kind of point in 1954. And I'm going to talk about these steps a little bit later. I'm going to skip it for now. I will come back to this because it's very interesting to compare. The final point about Dr. Drang and what he mentioned is that the Western TQM, that the word TQM is not from Japan. It's originally from United States, and a lot of people was practicing TQM. But that TQM meant by activity by the quality specialist. When Dr. Drang understood what the Japanese people were doing, they start saying that that's not Western TQM, it's a company-wide quality control. And what it means by company-wide is that frontline workers and the operators are involved in this activity. That's one aspect, but also the involvement of multiple managers. And that's the uniqueness of the Japanese CWQC, as he said, company-wide quality control. So these are some of the major influences of the Western thinking, which when we imported to Japan, we start attaching the word KANRI, and we grew the meaning of it. And from here, I'm going to start talking about how from here we start modifying and changing the meaning of KANRI. The first person I talk about is Nishibori, sorry, and he's not that famous outside Japan, but he is a critical figure for us. Why? Because he is the guy that was working for, I believe, Toshiba, and he was supplying to the GHQ. And when he was supplying his product to the GHQ, he was challenged by them to submit the control chart. Nishibori didn't fully know about the control chart, and he asked the GHQ to explain what is the control chart and why do we need that. He didn't get a good explanation from those people who he was directly in contact with. And so he searched inside the GHQ for someone who can explain that better, and that someone turned out to be Dr. Deming. Dr. Deming was in Japan at that time to do a census in Japan to research on the Japanese public. And he was trying to convince the Japanese government to do sampling to understand more about the Japanese population. Eventually, I'm sorry, but the Japanese government didn't take the sampling approach, but they took like the whole wide survey, countrywide survey of the population. So Deming was sort of frustrated that his work wasn't appreciated, but then he ran into Nishibori and he started talking more about the sampling and also the control chart and that kind of topic, application and quality. Nishibori was delighted with the work of Dr. Deming, and that's how Deming was introduced to the Japanese society. But this guy is not also, he didn't always accept, he always modify. He always tried to modify in a way that makes sense to him. For example, he was a heavy critic on the Taylor's approach, Frederick Taylor. Why? Because his brother was operating a factory and he knew how Taylor treat the people. And the result that they saw was that not necessarily the Taylor is the best way, but giving a little bit more respect to the humanity will provide more better result. How can they involve the workers to participate in some of the improvement activity was critical. And so he didn't fully accept the Western way of QC, which was originally designed to be a QC specialist activity or quality specialist activity. He was starting from the beginning. He was thinking, how can we convert that thinking to more company-wide and involving a lot of more people, especially from the shop floor, to participate in this activity. So the early sign of the uniqueness of the Japanese systems, including TPS or Japanese TQM, can be seen in Nishibori's philosophy. The other thing about Nishibori is he is significantly older than the other pioneers of the quality in Japan. So by the time after the war, he was head of the Scientists Association, which is the original entity which eventually became JUSE. And he was hosting a lot of parties. And inside the party, there was, and party doesn't mean just drinking alcohol, but they talk about a lot of Western philosophies and some of the scientific accomplishment in outside Japan, which they thought they would like to introduce. And inside this party, there was a young engineer such as Dr. Ishikawa and Dr. Mizuno, who we know as the father of TQM. Yeah, and I'm quite sure everybody heard about Mr. Ishikawa. He is known as the father of the Japanese TQM. And he also had a very interesting network, which his father was the head of Japanese Economic Association. So as soon as he found out that, this Deming is coming and Deming's lesson could be valuable for the business, he contacted his father to promote this arrival of Dr. Deming, and he invited a lot of business person to participate into Deming's seminars. And that's one of the big reasons why it got a high publicity among the business people to influence and get the start working on and listening to Deming on the quality control activities. In 1954, Dr. Ishikawa also published his approach on quality control. And the interesting thing about this 7 is that it's somewhat, I wanted to compare. I'm not trying to say who's right or wrong, but it's kind of highlights the difference in the nuances of how Western TQM is designed and how Japanese TQM was designed. And the part that interesting to me is when I follow the steps of Dr. Durand, I can see that he's trying, and this happens in a lot of places, is he's trying to create a data, right? He defined what's important and then define how to measure it. You measure it and see the deviation in the data and understand the reason for the gap and take action about it. Dr. Ishikawa is saying something slightly different. And what he's saying is that we need to have a good quality standard. Based on the quality standard, we need to develop a technology standard and work standard. We need to train the people on this, let the people follow the standard work. And then whenever there are deviation in following the standard, you take corrective actions. And that is his approach on quality control. Yeah, and it's very interesting to see this difference in the two at the very similar timing on the very similar topic, because I still see this difference. A lot of people who's outside Japan, when they talk about quality, is that they want to see the data first. Data, data, data. But when I work with Toyota people, and they will say standardization, standard, standard, standard. Follow the standard. And when there's a deviation, let's work on those deviations. This thinking is also apparent. This gap in the difference also appears on the Fishborn diagram, right? And I think the English name to the Fishborn diagram is called the cause and effect diagram. And if I generally summarize how this is used, is the problem solving tool by using a lot of brainstorming. Well, that's not how Ishikawa invented this tool. Jusei published the celebration of the 100th birthday of the Dr. Ishikawa. In that article, there's a lot of students, former students of Ishikawa, mentioned about how he was introduced. And one of the hot topic on that publication was that everybody directly trained by Ishikawa will say they were not trained by Ishikawa to use this as a problem-solving tool first. The original name that Dr. Ishikawa gave to this tool was in Japanese is Tokusei Yoinzu, which means that characteristics and factors. So we define the characteristics, quality characteristics that we want to accomplish, and define what are the factors that contribute to that characteristics, and let's make sure that we set standards to those characteristics. So it wasn't intended to be a problem-solving tool, but it more intended to be a guide to design standard. And by designing the standard, how can we design the KANRI activity? And when I read like some of the Ishikawa's the old books, where does this fishbone diagram appear first is in the KANRI section. When he talk about the KANRI of quality, there he start talking about the fishbone diagram as being an important tool to make sure that all the factors that contribute to the, building quality is included. And I think we see this kind of issue in a lot of places, right? Like somebody decided to change the material, but we don't make sure that the other factors, such as machine or methodology, is impacted by the change of material. We just change the material. And later on, we found out from the data that said, oh, somebody changed the material, but we didn't make sure other standards are following that change, accepting that change, and we make a lot of defects. Another important note is that Dr. Ishikawa is originally a chemical engineer. He's not a statistician. He's not a major in quality. He's a chemical engineer. So everything he does, he wanted to apply here is basically how chemical engineers design experimentations, right? They don't randomly change the component factors that could potentially impact the outcome of the chemical experimentations. They define these details and introduce one variable at a time and make sure they understand how those variables impacts the outcome. That's how the chemical engineers work. By the way, I use the word design of experiment. Nishibori and Ishikawa both has published a book on design of experiment, and design of experiment is also creating a very interesting role in this development. So the way we use this fishbone diagram wasn't originally a problem-solving tool, but it was a guide to design KANRI activities. How can I design a better management system? How can I design better control? How can I prevent problems was the original thinking of the fishbone diagram. One interesting story, maybe I'm deviating too much, but a cause and effect diagram, this English name, Ishikawa and his students claim that it was named by Dr. Duran, but I always doubt that Dr. Duran was fluent in Japanese. It probably because the translator of Dr. Duran gave that kind of translation, but did the translator really understand what this tool is for? I don't know, and probably that's where the cause of the misunderstanding happens. Yeah, and I think it's about time to reflect on some of these translations. There are many bad translations, and from here, I'm going to move on to this group of people called Dr. Mizuno. Dr. Mizuno is not so well known outside Japan, but he is considered as one of the founding fathers of the Japanese TQM. And it's important for me to mention him is that he was involved in Toyota's implementation of TQM. Both Dr. Ishikawa and Mizuno was involved, but my understanding is that Mizuno was visiting Toyota more frequently. As far as I understand, every quarter he would visit Toyota to have a TQM, sort of like a summit or steering committee, and he was involved in the participation of that. Dr. Akao that I'm mentioning here, I couldn't find a picture of Mizuno, but I could only find Dr. Akao, but it was one of the students of Mizuno, he supported the development of this activity called quality function deployment. And I believe he worked with Toyota Automotive to implement some of this QFD thinking. What is QFD is that to design the product and production processes with the quality functionality in mind. And the reason why I really enjoy Dr. Akao's work is that he shows some of the intermediate example of how he and the QFD people develop a final documentation. There are many copy of QFD, and also another word is the KANRI, the X matrix and things like that. That is from this group of people, but Dr. Akao is showing how he and his group came to that format of the paper. And when I look at the original format, it's a bunch of fishbone diagrams, right? You see that it's in Japanese, but you see a sample fishbone diagram of what kind of quality characteristic they want to accomplish. Therefore, what needs to happen in each process. And you can see he has made a lot of interesting fishbone diagram examples. And by using this fishbone diagram to a more sort of like a chart format is the progression of how QFD was developed. One of the tools that was developed from the QFD function is called the QC process chart, quality control process chart. So this tool is designed, and when I add the translation, is to highlight what are the control points, which was originally mentioned by Dr. Duran. And with those control points in each process, what are the control methodologies? And what I mean by methodology is who is responsible to conduct, at what time, what frequency, like is it at the beginning of the shift, during the shift, or is it after X amount of units that produce? Is it about X amount of time that pass? We highlight those control methodologies on this QC process chart so that we don't mess those control. And this becomes a foundational tool to design the KANRI activities on the shop floor. Every one of them says control, but everything is written in Japanese. We'll say KANRI, which means that manage. So instead of saying randomly, saying like, oh, every once in a while you do this kind of quality check, this document highlight specifically who needs to do at what kind of check at what kind of timing. This tool is not so publicly known, right? I haven't seen many people introduce this tool, but many people, especially in Toyota, will respect this document and they look for this document. And I can see that in the quote from Mr. Shoichiro Toyoda. He was also another important leader who implemented the TQM, TQC in Toyota. And one of the interesting quote he said is that our original detailed effort in the factory, such as Pokayoke and QC process chart, made our TQC successful. And I found this quote extremely interesting because a lot of people talk about Pokayoke, right? There's a lot of posts about Pokayoke, and but there's not many people talk about QC process chart. But from Mr. Toyoda's point of view, these two are almost equally important for the success of Toyota's TQM activities. And that details thinking is the background behind the success, which we often neglect. Now I'm going to talk a little bit about TPM. TPM also has a very strong connection to the word KANRI. Why? Because the Japanese Management Association was conducting a study group, and this study group was called the Equipment KANRI Group. So how can I not necessarily the word maintain, but how can I manage the equipment better? That was the group's mission. And in 1971, they became an independent organization called the JIPM, and they started this campaign called Total Productive Maintenance. But so the TPM here is that have a very strong influence from the Western maintenance system, but also very influenced by the TQM thinking, right? One example, one of the first book that Dr. Nakajima wrote is not about TPM. The first book he wrote is called Zero Defect. So he was studying about the zero defect activity in the West, and also he was studying about the TQM in Japan and wrote a book about it. And about a year later, he started getting involved in the TPM activities. One interesting story about Dr. Nakajima, maybe he's not a doctor, but Mr. Nakajima was that he was playing golf with Taichi Ono. And when he was playing golf with Ono, and it sounds like they played quite a lot. And Mr. Ono asked Mr. Nakajima, like, why are you saying preventive maintenance? Because the word maintenance in Japanese already have this notion or meaning to sustaining all functionalities of the equipment. So by saying preventive maintenance, you almost saying like prevent maintenance, which seemed like the duplicate meaning. And Mr. Nakajima didn't have a answer to the word. He almost thought that, just stick to the word maintenance will be enough. So obviously the two know each other and they've been closely working to each other. And one of the first company to be successful in TPM was Denso, Toyota's Toyota, and also part of the Toyota group. So they kind of know each other and influence each other. One important note here about TPM, as I said, they have a strong influence from TQM. One example here is that there's a gentleman working, I would say, a colleague of Nakajima, and this gentleman called Mr. Takahashi. He wrote the book, and inside his book, he was showing another fishbone diagram. Once again, this fishbone diagram was not intended to be a problem-solving tool of the reason cause of the downtimes. It was a tool to design how can I create a preventive maintenance activity and looking into those factors, what detail aspect, what detail standard we need on each element is the idea behind his book. There was also a small question from Dr. M about the OEE. That's a very interesting topic. I still studying about this thing, but what I found out so far is that this gentleman called Mr. Takahashi, he is the one that in 1975 inside his book he wrote this KPI called the 設備有効稼働率, which basically means, if I directly translate, it means equipment effectiveness availability. And inside, he showed an equation of time availability times speed availability, speed productivity. So they're talking about the within the current OEE calculation, the OA factor, availability factor, and they're also talking about the performance factors. That inside this Takahashi book, it doesn't talk about the quality side. And the quality was included, I believe, in this book in 1982. That's the first textbook introduced by JIPM. And inside this book, there's a talk about the calculation of OEE. And Takashi wrote another book in 1983, and inside that book, his equation changed, and he included the quality rate in his equation for the calculation. And I believe that's where the root of the OE equation came from. I'm still confused because Toyota used the same word that actually Takahashi used, the word called kadoris, but that meaning is not availability. The meaning of that word is how much of the product that we produce today is sellable, meaning how well are we producing just in time to the market. That's the meaning of that word. That's how Toyota is used. But it's not clear if Takahashi used in that way. I don't think so. And I think that that's like a huge gap that we see. And that's why I kept it red is misunderstanding between the two. Now I'm going to go how these activity was connected to TPS. And the important focus here for me is that it's about the standardized work, right? So when Toyota was introducing TQM, Taichi Ono, there was an episode of him sitting in the back of the classroom with his quietly listening to the story about TQM. And apparently he didn't say anything, but he just went back to the shop floor. But how can I see how he and his team had integrated the TQM thinking? And I always start with the standardized work because I believe the standardized work is not I, but I think not my coach and everybody taught me TPS will say the standardized work is the foundation of TPS. And inside here, there's a quality check mark. Where does this quality check mark come from? And it comes from the QC process chart. It is connected to that tool. I've often seen people randomly adding this symbol, but this symbol is not a random opinion of those people who are writing the standardized work. It should have a very strong logic coming from one is from the QC process chart, and based on the QC process chart, we should have a work standard on this quality check on how it should be checked so that the check is not random activities. Another important thing is as we focus a lot on doing Kaizen or trying to get more efficiency out, a lot of time we sacrifice the quality check. We violate the quality issues, and that will become a negative impact in the future. That's why when we have a quality check and we're going to ask somebody to do a check, we need to have a very strong technical background explanation on how that check will be done. There's also another interesting story about how TQM activities is connected to the standardized work. Is one long time ago, I visited the factory and with my father, and my father saw in-process inspection that was done by the operator, and he just shook his hand and like this is a big chunk of waste. And when he saw that process and when he made a comment, the people around there is like shaking his hand and like, especially the quality people said, look, the TPS guys here, they are here to destroy the quality. And I stayed in the factory and said, no, you haven't understand what he means. Let us try to Kaizen. And that quality inspection was happening every 10 pieces. And it took them about 5 minutes to conduct that inspection, internal in-process inspection. It has a lot of waste, but the other waste was that the takt time was about 3 minutes, and the operator was waiting in front of the machine for good like 1 minute or minute and a half. So what we did is that we look inside this 5 minutes of the process inspection and divide that 5 minute into 10 because every 10 pieces we need to do this inspection. So and we created the blocks of 30 seconds of inspections. And we changed the standardized work of the operator that every cycle they do 30 seconds of some part of the inspection. And so instead of waiting in front of the machine, we ask them to come to the inspection table and conduct, basically 10% of the inspection work by using the waiting time in front of the machine, and we convert that to an inspection time. By doing this, we avoided downtime, we got the efficiency, and also we got the quality better. And that's because it become more consistent work to do inspection. Very often you tell the people to do inspection every 10 pieces, but they forget, or they did it on number 12, or they did it on number 8, and the inspection becomes random. But by separating into the 10 segments and building that into my standardized work, and the standardized work that I make is not this one, but I will see 10 up and downs 10 times, but each time it touches the different element of inspection. And that way it was easy for the operator to conduct. So the purpose of standardized work is not just filling out forms. The purpose of the standardized work is, this kind of thinking, this kind of sort of dividing the elements into increment is a very important thinking for maintenance, for TPM activities, right? Because one of the problems that I see in a lot of factories is that I have a daily maintenance, I have a weekly maintenance, I have a monthly maintenance, and every once in a while, all of them show up on the same time, and the maintenance guy say, hey, I cannot do all of them. I'm going to skip it. I'm not going to do all of it. And that's the problem. I always say the weekly maintenance have to be divided into 5 because we work 5 days in a week. And every day you do one portion of that 5. You don't try to do all at once. When you do that, your workload will fluctuate and you won't be able to levelize the maintenance activities. So it's this kind of thinking in standardized work is critically important to build quality into the process, and also to make sure that maintenance activity is done, and also getting the efficiency. So the purpose of standardized work is not just about filling out the formats. It's about defining what's the best way to make it reliable, repeatable, efficient, effective, and simple. And the management and different functionalities such as quality and maintenance people and the shop floor people, Gemba people agree and have a handshake, say, hey, if we follow this standardized work, we can accomplish everything we need to do to make sure that the quality and maintenance and every other functionality is satisfied. It's a common language. That's how standardized work is used. And we have to make sure, for example, quality people have to make sure they look at the quality QC process chart to make sure that these things are followed on standardized work. And that doesn't cause some kind of fluctuation on the work. Same thing for the maintenance people. How can I design the work for the maintenance people? We can't randomly say, hey, do this every month, do this every week, and you guys figure out how. We need to have a standard to make sure that those things can be done by the maintenance people without having a huge up and downs or the need to come on the weekend to cover for some of the maintenance activities. Now, when I designed that standard work of the inspection in the factory, what did my father say? My father said, yeah, you need to think more. That part of standard work is not the entirely TPS. There's another aspect of TPS, and that is the mechanism aspect, right? And mechanism, what I mean is this specific process of structure, and how can I make sure these things are tightly in control and also followed? And the concept that my father was challenging was visual management, right? Don't just satisfy by designing that standardized work that was easy to follow and respect the quality and the efficient. How can you make that work more visual, right? And one of the things that he always said, and I always follow, is the first thing that Taichi Ono visualized was not the KPI board or not the unknown light, or whatever the things that most people focus on. The first thing Taichi Ono focus visualizing on the shop floor was standardized work. He wrote the standardized work on the A3 paper and posted on every station, and he gave a name called Kanban, which confused a lot of people. But that was the original visualization of TPS. And from here, it started to visualize other things, which is physical, some kind of physical object or physical way of showing that is important for TQM, TPM, and also the standardized work, right? So visual management, I'm not sure if that's a very good way of translating the work, but also I would like to say is like it's in Japanese we call visual management as meta-media kanri, but if I try to translate it as much as possible, it will mean like management confirmation with their own eyes. How can a manager walking by the area can visually check and see that everything is under control and prevented, right? So one of the things that I did with that process that my father challenged was like, okay, how can I visualize that, the operator is on the number third step or the seventh step, right? Because there was a little bit of confusion, right? Sometimes he thought I'm on the number 5 step, but actually he was on the number 6, and he almost repeated the same inspection work. Obviously, working all day long, a lot of confusion happened. So I tried come up with this board with the number on it. And every time they complete a task, I turn the board to show the next cycle when he returns is on cycle numbers, the appropriate number. The other thing that we visualized was the transportation case. We changed the transportation case from random number to size of 10, and the 10th slot is always in red. And that's the slot that I put the inspected material into the package, but also put the inspection document in that slot. That way, we always make it visible that, did the operator really follow the step and easy to follow. And this is the thinking that I think they've worked a lot is to how can I visualize some of those important characteristics for TQM, TPM on the shop floor. One example in the welding area, like one of the very interesting poka-yoke that I've seen was that the welding operator is using a fixture to do their job. Once the fixture is done, they return the fixture to a holder. This holder is designed in a way that it rejects if the fixture has changed the shape in the middle of the cycle. That way, they always assure a quality. So it's a very important tool to make sure that the fixture is always in shape and guarantee the quality of the process. That has to be visual. Another TPM activity that I saw in the weld shop that was very interesting is that they have to change the weld tip at X amount of hours. How can they visualize? They put those weld tips right next to the hourly count board. Every X amount of hours that they need to change the weld tip is they locate the slot for the clean weld tip and the dirty weld tips. All the team leader have to do is every time when they start running that hour, they have to change the tip to guarantee that TPM is done. I use similar thinking like for toolings and other devices that, I put next to the hourly count board and visualized when these maintenance activity have to be done so that there is no excuse for skipping that kind of TPM activity, right? And it goes back to what Ishikawa mentioned in his 7 points is like he said that we need to make sure that check it is that the work is done according to work standard. And if the work is not done according to the standard, we need to take corrective actions. At this time, the Toyota guys are saying, well, we don't just keep that in the form of papers because nobody's looking through the work standard all the time. How can I highlight that on the show floor? And we always follow. That will assure that the quality and maintenance activity is done, right? And that's the interesting part of the integration of TPS, TQM, and TPM is that how can I develop a standardized work, and also how can I look into some of those physical aspects that we can visualize on the shop floor, and making sure that management continues to observe, and that is important part of the KANRI activity. Then we go to more system point of view, and one of the system aspect is that system is a little bit more flexible. It's a little bit more general. It gives you a little bit more room because there's a lot of change happening, and we need to make sure that that change works. This is the structure of the TQM activity that Toyota organizes. So based on the standardized work and the mechanism visual management thinking, they start to apply this philosophy to a lot of different functionalities and focusing on the quality and the cost and making sure every one of them has a standard and we follow the standard. And every time there is a deviation from the standard, we trying to highlight and problem solve. There is another interesting story that I would like to cover. When I read the Toyota's 75 anniversary, they have a very interesting notes on how TPM was introduced to Toyota. And inside that, Toyota talk about how they introduced the Ishikawa diagram to the factories. And when they said they did not say in this TPM document that they use as a problem-solving tool, but as a guide to design what kind of standards are necessary. And then they apply the control chart to the factors, to the inputs. And that was the explanation of the Toyota's approach on TPM, the TQM. And this is a slight difference I see in a lot of places because I see control chart to the result everywhere, right? We have, output and then how many defect we made and is that under control or not. I see that kind of chart, but have I seen any application of control chart to the input side? I would say very rare. But when I read the books on TEPO and also how Toyota applied it, it's interesting to see that they are focusing more on the inputs. And from the input, I think there's an important part of the discussion which is happening. And I think I would like to go because I think Toyota simplified this process today. And that is because they talk a lot about change point. So when I try to understand the logic behind what they are saying is that we have control point. We have things that we need to have things under control. But inside those control points, there are things that could change and there are things that could not change at all. For example, when I use men, first shift and second shift will have a different operator. That's a change point. And I'm not going to try to make an operator work for 2 shifts because there's no way anybody can work like 16 hours a day. It's crazy, right? So change point is people. That's a change point. So we have to highlight it. But the skill set that they use cannot change. It needs to be standardized, and it needs to have work standards to back those skills. What does skill means, right? I cannot have an operator who's inspecting a product in a different way. I cannot have an operator who's doing a maintenance work in a different way, right? Everybody needs to be standard. I know we all have different people working in that particular stations, but they all need to follow the same rule. Inside this change point, there are multiple types of change point, and one is the intentional change point. The other one is unintentional change point, and the last one is abnormal point. What I mean by intentional change point is like the operators have submitted his vacation plan. Like, I don't know, it depends on the company, but 1 month before the vacation, he goes to vacation, he submit the paper that he would like to take a particular week off, and he haven't violated any rules. He still have a lot of legal holidays left. It's being approved by his managers. He goes off. That's like an intentional change, but we know that change is coming on that particular week, and the senior management have to be prepared for that change. Another type of change is unintentional change point. In a particular morning, the operator is completely sick. I cannot come to work. I notify um, my manager that I cannot come to work. I still have my legal holiday left, so I'm going to use that to cover for today's loss. I'm not doing anything, illegal. It's part of the deal. And in that case, the team leader who gets the call have to report that one of his members is sick today. So he would like to get a replacement operator. And the group leader and the foreman of the shift will make sure that they have a reserve under their control, and they will deploy some of the people to cover for the slot so that this absence doesn't impact the performance of the line. So even this was unintentional, they gave a systematic way of covering those unintentional change points. The last one is abnormal point. For example, operator wants to go to the bathroom, operator got injured. In such case, we need to highlight that point by pulling the undone. Undone goes on. The team leader will jump in temporarily to cover for the abnormality and make sure that that change point doesn't make a significant impact to the business, right? And this is, I think, one of the philosophy of thinking, a systematic approach of Toyota production system is that they reduce the weight, eliminate the waste, and by eliminating the weight, they create a excessive capacity or excessive power. So they keep these people as a reserve just in case to cover for some kind of unexpected things to happen. If there is no problem going on, they will ask these people to focus on Kaizen, continuously improve. And that's another important part is that the Kaizen is a change, right? But they don't randomly introduce changes. They introduce this change point in a systematic way. So when the change is implemented, they make sure the management is always on the shop floor observing and making sure that that doesn't have a negative impact on the performance. If there is a negative impact, no worries, just make more Kaizens. So that is the systematic view of how they approach TPS, TQM, and TPM is like they have a lot of control points and they standardize it. But once in a while, there's always a change point. Highlight that and make sure that doesn't have a negative impact. And also continuously introduce a change point called Kaizen, right? We have to change, we have to improve, but introducing a small change at a time and making sure that change is included in the standardized work to make sure that we have a good impact on our KPIs. That's kind of design of experimentation is one of the core thinking behind all of the three philosophies that I talked about, which I think we kind of lose that fundamental thinking in a lot of places. They just get excited about the new words. So yeah, so my summary of this whole thing is that a lot of people trying to understand this TPS, TQM, TPM based on the Taylor's. I'm not sure if Taylor actually said it, but some of the Taylor's followers introduced this function-oriented organization point of view. This is very silo mentality, and that's the view that all three of them trying to change is that no, it's not a single functional topic, it's a cross-functional topic. And we need to focus on this KANRI activity, which is, I typically use the word manage, but it's somewhat maybe a level lower level than the Western manage would manage. It's somewhat more specific, somewhat more mechanism driven, where we have a lot of more detailed design from all the way from the product and the process designing point of view. How can I make sure I control? How can I make sure I prevent these things so that I can get a business result. That's the fundamental thinking that that's living inside all three of this philosophies or thinking. And when I try to integrate these things, I think one of the things I learned from my father is like it's not 1 + 1 + 1, because if you do that, people will be overloaded and you kill somebody, right? I've been to some factories where they're trying to introduce autonomous maintenance to the operators. I look at the standard, it says like it takes 30 minutes to do the maintenance, the autonomous maintenance, and they're giving only 15 minutes. That's not possible. It's not possible. You can't give that kind of responsibility to the operators. It doesn't follow any kind of logic. So what I always challenge is that, right, trying to come up with a point. What are the key points that I need to do to make this quality better in this process? What is the key point of maintenance? What is the other key points that we have to respect in this process? Highlight those control points, and then define those control methodologies and frequencies so that I can design the work better, right? And be specific about it, eliminate the waste, and come up with a combination of those lines that makes us standardized work that is repeatable, that is efficient and effective to some of these functionalities that I want to accomplish. Once I define the standard words, come up with a visual management, a way of a manager can directly see that if they are respecting the standard words, see if they have respected the TQM or the TPM, so that they can instantly make sure that they can take corrective actions. But it's operation, it's day to day. We have a lot of changes that happening every day. So how can I highlight those change points in these processes? And change point go back to the beginnings. Once I find out there's a change point, what are the change methodologies or countermeasures I need to take? Is there a standard work of accomplishing that? For example, if I forgot to mention, but when there is a replacement operator, a reserve operator joining a process, the first responsibility of the team leader for that particular, I would say, first hour or so is focus on training that particular reserve to make sure that person can follow the standardized work. So the team leader is constantly challenged on Kaizen activities, but when you have that kind of change happening, that's the priority. That should be the focus. That you should not ask the team leader to do work on anything else, right? I have a new guy coming into my process, but right now I'm working on my Kaizen. It's a no comment from the team leader. It's just say on the production analysis book that first hour I focus on training this person to follow the standardized work, which is a legitimate reason to be done. I don't expect any kind of Kaizen to happen on that hour, right? We have to make sure that the change point is under control. Then once it's under control and we know that that person can follow the standard, we can work on other topics. And that's the summary of my understanding of this word KANRI. I think it's good to translate the word KANRI as management, but I think it's far more detailed, technical driven, and highlighting those KANRI points, control points. And from there, we're designing the standardized work and mechanism to make sure that management is always observing and monitoring the system. Thank you. And that's my summary. Thank you.
Thank you, ObaSan. Thank you. You can stop sharing.
Yep.
Well, thank you very much. And one thing for sure, I think that many of us would now understand the common base for TPM, TQM, and TPS. Thanks a lot. And Dr. M, as curious, is going to again be behind you, requesting you to solve the issue called overall equipment effectiveness. In any case, thank you very much, sir. Have a good day, and for me, have a good night. So, namaste, take care, and I'm going to stop recording. Thank you very much.
Yeah, thank you very much for this opportunity, and I always enjoy your inputs and also challenges. Right, it's a good topic that I wanted to summarize for a long time. I think I'm going to continue to work on this thing, but I think I was able to cover the main theme. So thank you.
Yes, sir. Thank you very much.